How do they make bog standard household batteries like AA or AAA? What energizes them? Well, I've already answered this for you, Tony. Science! But there's obviously more to it than that. And as I explained, I think, a few days ago, why is it you always get the wrong blasted size? You get the little fat ones when you want the little thin ones, and you get the little thin ones when you get the little fat ones, and you end up with loads of batteries you don't need. Anyway, that's just me because I'm stupid. Maggie Goddard is from Fun Science, Hands-On Science for Kids. Maggie, good afternoon to you.
Hello there.
Not just hands-on science for kids either, Maggie, because most of us really weren't paying that much attention in science at school.
Oh, believe me, I learn a lot when I'm doing it as well.
Right, let's talk about batteries, because it is chemistry that's going on in here, isn't it?
It is, yeah. Basically, it's a chemical reaction.
Okay, so your bog standard battery, before we enter, batteries that can power rabbits playing the drums, what's in a bog standard battery and how does it power up?
Well, the basic explanation is that you've got your negative end and your positive end. You've got to make sure you get them the right way around when you plug it in.
Right.
The negative end we would call the anode, and the positive end we call a cathode. And in the middle of them is something called an electrolyte. And basically, a chemical reaction takes place in the anode, so in that negative end, which makes lots and lots of electrons. And these are the things that carry electric charge. And a bit like with a magnet, how opposites attract, the electrons want to get all the way around to the positive end, to the cathode. But they can't, because that electrolyte is in the way, a bit like a barrier. So when you connect something to the battery, it completes the circuit, and the electrons can get to the other side by going through that circuit, a bit like a bypass.
Okay.
And they will power anything that they go through. So that will be a light bulb or an electric toothbrush or your remote control. So basically those things turn on as a byproduct of the electrons trying to get to the other side of the battery.
So the power then is a byproduct of that chemical reaction?
Yeah, basically all it is the electrons are travelling around your circuit to get to the other side of the battery, to the cathode. And along the way, they will power your device.
Okay. Now, when you have, I remember this from chemistry. When you have a chemical reaction, something normally happens. Smoke or fizz or something. So what's actually happening in a battery? Because it's not melting, is it? It's not fizzing. It's not producing anything apart from these electrons. What is that chemical reaction?
No, so you won't always get your fizzing or things like that. Normally, you can feel sometimes that a battery gets hot. That's generally what you're getting from that chemical reaction. So there's a bit of heat. But the newer batteries, the alkaline ones, are a better technology. It's a better chemical reaction, which means that they don't tend to get as hot, or you don't feel it through the casing. So,
okay, so alkaline batteries, which were sort of this major breakthrough, and I'm old enough to remember when they were first advertised, it was like sort of, we've come out of the dark ages of really rubbish batteries. What's the difference in an alkaline battery to your bog standard battery?
So your alkaline batteries are, they have better chemicals in them, basically. So they're able to do the chemical reactions faster.
Right.
So they're good at things that need a lot of power all at once. So things like your remote controlled toys and things like that. So things that need a lot of power, they're good for. The old zinc carbon batteries are better for things with sort of low energy consumption. So things like your TV remotes. So you can use them for longer, but for sort of lower powered things. But for things that need more power, you want your alkaline batteries, really.
So I'm guessing once all the chemical reaction ability is gone, that's when the battery's flat?
Yeah, so eventually the chemical reactions stop. Every chemical reaction runs out eventually, and then it will stop making those electrons, and then the battery will run out. You can get the rechargeable batteries, and that just basically is when you plug it in to your mains electricity, and it will reverse that chemical reaction so that you can then start making the electrons again to start going. So that's what happens in your phone battery and things.
So that was the question I was going to ask, because obviously that chemical reaction doesn't obviously apply in a rechargeable battery, but clearly it does. So by the process of charging the battery isn't that you're storing the electricity, you're reversing the chemical reaction in it.
Exactly, yeah. So
didn't know that.
Yeah, so it just reverses it. So your sort of older rechargeable batteries, the one that you could get that you could plug into the mains in that little device, those won't last as long, because when you recharge it, it sort of changes it a little bit. It won't last forever. You won't be able to recharge it for the rest of time. and not until they are able to use the same sort of science that they use for car batteries, where it's recharged by motion.
Because that's really interesting then, because when we say we're recharging a battery, you have this image that you're effectively plugging it into the mains and it's taking a little bit of electricity and storing it in a magical way, when in fact actually it isn't. It's a chemical reaction. It's a reverse chemical reaction.
Yeah, exactly that.
Well, blow me down. I never knew. Maggie, you are a brilliant expert. Thank you so much for joining us this afternoon on BBC Radio Bristol.
Oh, thank you for having me.
My pleasure. Maggie Godden there from Fun Science, hands-on science for kids. And there you go. Tony, your question, your answer done. And we've all been getting it wrong. We don't recharge our batteries. We're just doing chemistry.